Hello there, and welcome back on LabHub. So in this video, we're gonna talk about the basics of the special relativity by Albert Einstein. And this is a really important thing to understand the universe, especially astrophysics. So at first we need to know one exact thing. We got our planet, the Earth, right? So in case of special relativity, the Earth is inertial reference frame. And every inertial reference frame has two postulates. A postulate number one, the laws of physics, and one, the same in every inertial reference frame. Right? Right. So if you are a person, no, let's do it here. If you are a person staying at rest and you see a train where some person throws a ball upwards. For this person, the ball moves with a constant velocity, right? And upwards. But for you, this ball moves with a trajectory like this, in a projectile motion. But the speed of light, usually represented as this sign, c, is the same in every inertial reference frame. What does it mean? For you, with a velocity of 0, the speed of light is 300 million meters per second, right? I'll do it like this because it's too many zeros to draw. And for the same person in the train, the speed of light will be the same, 300 million meters per second. Moreover, if you are in a spacecraft, let's draw a spacecraft like this, and you move in this spacecraft with a velocity very near to speed of light, like 299 million meters per second. Guess what? Right, the speed of light for you is still 300 million meters per second. So what can we say about it also? Yeah, that speed is relative. And moreover, another example, if we got a car moving at a velocity of 19 for a zero velocity observer, and we got another car with a velocity of 100 meters per second or kilometers per hour, it doesn't matter, for the same observer. For a person sitting in a car number one, in this one, velocity of car number 2 will be only 10 meters per second or kilometers per hour. Doesn't matter. So, if you have velocity of 0, the speed of light moves with the same speed both for you and for someone moving. But if your velocity is 0 and you see some object, velocities are relative, and they are very relative. So even if you move a really high velocity near the speed of the light, light is still moving at a velocity of 300 million meters per second. And this ain't because we got no technologies to accelerate so much or something. This is because c, as a speed of light, is a universal speed limit. This is a speed limit of the universe. And what a conclusion for it all. Let's think. If you stay at rest and someone in the space moves near the speed of the light, like in this spacecraft, and you are on the Earth, right? This is the Earth. what will be? You will experience time differently. Why? Because time ain't a constant. This is another thing what special relativity tells us. Time ain't a constant flow, as Newtonian prediction. So Newton predicted that time is a constant flow, that the same at every piece of the universe. But Einstein broke this down. And he said that time is relative to and relative to the speed. And the time goes differently, at different rates for different observers. So for this guy, time is basically slower. Let's represent time as a red line. Time is basically slower for him as it goes for this guy. For this guy is way faster. How can we explain it? And how maybe we can prove that nothing can move faster than light? Right, let's start with the first one. How we can explain it? There is a paradox called the twin paradox. The exactly and the absolutely identical two twins, but the twin number 2 got into rocket moving really near the speed of the light. 299 again, millions meters per second. Millions meters per second. If he do a circle around the Earth with this speed, for him it will be just a few seconds, maybe a minute. Not so many time will pass for him. But relatively, he will spend way more time in the space, outside the Earth, than this twin for him. So this twin number 1 and twin number 2, right? So twin number 1 is living his normal life, and the time for him goes as it's supposed to be. But for this twin, time will go away faster when he's moving near the speed of the light. And he will come back on the Earth after his expedition or something. Way it will not be so old as twin number 1. It called the twin paradox, and it was proved and confirmed. But let's do another thing. How can we prove that the speed of the light is the universal speed limit? Y'all see the signs like speed limit of 50 miles per hour. You definitely have seen them on the roads. But why the speed limit for the whole Earth and for the whole universe and for the whole world is C? Why is it like this? We can prove it. We all know a famous equation, E equals mc squared, which is a mass energy equivalence. Doesn't it look familiar? It definitely is. This is the exact formula of momentum. In the another form of this is momentum equals to mv divided by 1 minus velocity squared divided by times speed of the light squared under the root. So what can we tell about it? If something moves with the speed of the light, right, the velocity in that case equals c, what will be? Exactly, it will be 0. So therefore, we need an infinite energy to accelerate an object to the speed of the light because of this equation. So more speed needed, the more energy needed to accelerate it. It's really common and we know it. Or more mass means more speed needed to accelerate it on this energy, right? And all this kind of stuff. So that's why no object with mass can have a speed of light, can reach the speed of light. At most, again, be really close to it, but it's extremely high amounts of energy needed to accelerate it to it. Okay, can we somehow maybe prove it else? Or how can we prove that nothing can be faster than the light? Because if we got the zero here, okay, it can be exactly the speed of light, but maybe it can be faster than light. No, it can't. Because of another equation of delta t. Time equals delta t O divided by 1 minus velocity squared divided by speed of light squared. Okay, we got here a velocity of speed of light. Time will be infinite. Okay. But if we got something bigger than the speed of light, what we'll get? We get a negative number, right? Because if we represent a v as 2 and speed of light as 1, just mathematically. So therefore, there's 1 minus 4 under the root divided by delta t. It literally can't be like that. Mathematically, it's incorrect. Physically, it's incorrect either. So nothing beats the speed of light. So this is exactly how the special relativity by Albert Einstein works. In the next video, we will break down how does the general relativity works, and it's way more interesting because it really takes more about the whole universe, about the gravity. Yeah, it works with the gravity, it works with the time. So general relativity for me is way more interesting than special relativity, and I hope you will find it easier too.